Alright, so now we're beginning chapter 9, lesson 5. Chapter 9, lesson 5 is the last lesson of chapter 9, and that's a really short chapter. It's the shortest chapter in our book so far. Only 5 lessons to deal with our relationships and graphing relationships. Now, when I look at it, then that means that tomorrow is my test, and tomorrow is Friday. Once again, I don't help you on the first day of the test. I'm not going to answer questions and tell you how to do the problems, because I've taught you how to do the problems. You get one chance to show me that you can earn an A on the test. That means you have from Monday or from Friday's class all the way through Monday to get it done. You can rewatch the videos as many times as you want. They're still available to you on campus. They're still available to you on YouTube. They're still available to you on my class website through the school's website. You can access them at home, from your phone, traveling in the car, wherever you are. Sitting at a wrestling meet and you're really bored because you're there until, for 9 hours and you want something else to do, watch the math videos. They are so exciting to do. But this is your chance to get an A on your test starting tomorrow. This is the last thing that you'll see on your test. How to do a linear equation. Now, linear sounds like a big fancy word. It's not. If I look at the base word of linear, it's just line, and that's what we're talking about. Linear equations are that relationship between x and y, what's happening to the x to get to the y, finding that equation so I can make a line on my graph. If I'm just given my line then I have to plot my ordered pairs, make a list, and then see the relationship between them and get my equation. Now, I say ordered pairs. That takes them to a conversation about yesterday's lesson, 9.4. As I walked around, I told some people looking at their work that they need to show ordered pairs. And the reply was, why? You didn't show ordered pairs on your video? Well, I wasn't sure because I had done this a couple of days ago, but I checked. I did indeed show ordered pairs. In your book, they set it up as ordered pairs for you in parentheses. And then as I did it on my videos, I have them as ordered pairs on question 2 because I put it in blue. And then on question 3, I have ordered pairs. And on question 4, I have ordered pairs. See where I'm going with this? On question 5, I have ordered pairs. On question 6, I have ordered pairs. So I did indeed have ordered pairs, and what I'm talking about is I have to have parentheses. If I don't have parentheses and you show me your work where you have a number and a comma and a number, I'm going to count it wrong as incorrect work because that's not an ordered pair. When I'm doing these, I'm talking about plotting points on a coordinate grid, and I have to show ordered pairs. X before Y. With that, in our book, beginning of chapter 9, lesson 5. A linear equation, and it says a linear equation is what? Well, it's an equation that helps us draw a line. That's simple. That's easy. We can remember that because line is inside the word linear, and we know, because Mr. Barker said it 400,000 times on these videos, that an equation is a math problem with an answer. An expression doesn't have an answer. So as I look at it, then I'm going to look at this information I'm giving, talking about a blue whale. And the blue whale swims at a certain rate for a certain amount of time, and how far therefore does it swim? And then we're going to find a linear equation for however many hours it chooses to swim. So I'm looking for my distance in miles. That has to be my y. That is my answer. That is my dependent variable. It's going to depend on the relationship and the number I use for x. When I look at my x then, where my independent variable is, the work that I'm going to be doing, it can change. This whale may swim for 1 hour. The whale may swim for 4 hours. The whale may swim for 10 hours. That's going to change. So my dependent is going to rely upon, be dependent on, the independent and the relationship that it has. The relationship that it has, the math problem that I have to do with it, is I have to look at my rate. And my rate is my one that stays the same. I'm going to multiply by 3 because the whale will swim at 3 miles per hour. So when I talk about that, my answer once again is my dependent. My work that's being done to my variable, that variable is my independent. My constant is the one thing that continues to repeat. It's that relationship pattern. It's that rule that we have to find when we're doing these. So when I fill in my thinking line down there, then I know my answer, my distance is my y. My time, my independent variable, my x, And then my constant is going to be my rate of 3. So I know that this is going to be my formula. So when I look at that formula then, I can see that I can fill in my chart. And when I fill in my chart, we look at all sorts of different parts. So I'm going to repeat some of the points over here, but only because, not all of your problems are going to have a chart. So I'm just going to show you how you can show your work without a chart being there for you. So it is set up with all my X's, and that's just going across horizontally on my quadrant 1. Once again, quadrants on ordered pairs have a positive forward, positive up for quadrant 1. If it was showing me my 4 quadrants, I would have a negative and a positive for quadrant 2, a negative and a negative for quadrant 3, and then that quadrant 4 went forward for positive and down for a negative. These are always going to be just shown on quadrant 1, and my answer can be shown as a diagonal going up gradually. It could be a steep diagonal, it could be a low diagonal, or it could even go down. It just depends on where my relationship tells me to plot my ordered pairs. So when I look at it, I have my X, which is given. I'm just going horizontally across. And then I have to fill that chart in right there because I know my constant is multiplying by 3. The whale swims at 3 miles per hour. That has to stay the same. So my relationship is that I'm multiplying my constant and my X together. That's going to give me my Y. If I know what my X then is, then over on the side, if I don't have a box, then I can start building my ordered pairs. And once again, ordered pairs have to have the parentheses, have to be separated by commas. My X is always my first, it's my horizontal line. My Y then has to be what work is being done to the X, to the independent variable, with the constant. And so I just multiply them. 3 times 1 is 3, which they give me. 3 times 2 is 6. 3 times 3 is 9. And 3 times 4 is 12. So I could then plug that into my showing of work over here and show that my relationship is multiplying by 3. And then I know that my answers are 3, 6, 9, 12. If they have the chart, then I just fill in with the chart where I got my Y on my Y side. And so I make sure that I have my ordered pairs. So that's all of the showing of the work. And then I end up graphing it to have my answer. My line for my linear equation is going to be my answer on this one. Going from the linear equation to the relationship would be an answer on a different one. So when I look at it then, I just plot my ordered pairs. I have 1 and 3. So I go over 1. Notice that there's not a tick mark there or a line measurement for the odd numbers going up vertically. That's okay. I just plot it in the center. So I go up to the 3. And then I go 2 and 6. I go forward because I'm going to run. And then I'm going to go up because I'm going to jump. 2 and 6. So over 2 and up to the 6. And then I plot 3 and 9. 4 and 12. Once I've done that, then I have to make it a linear equation, and I draw a line to connect them. And if you forget that, read the directions. It says to graph the ordered pairs, draw a line through the points to show all the solutions of the linear equation. So if it says, well, are there more solutions, or choose a solution that's not in your chart, then all I'd have to do is go to another one and look at where it connects. So if I go to my 7, and I go straight up where that line crosses, then I know my ordered pair would be 7 and 20. Alright, so as I go forward, then I look at my second one. Beaded the graph shows the number of beaded necklaces here. Y, the ginger can make in X hours. So my X is how many we're going to make. No, my Y is going to be how many I make. My X is how many hours I'm going to work. Write the linear equation. So this is the one where the answer is the relationship, that problem in which we show. Write the linear equation for the relationship shown by this graph. Use your ordered pairs. And so my ordered pairs build this chart. My ordered pairs, so my black numbers are my X. I'm going to 1, even though it's not numbered for me. I know it's 1 because it's between 0 and 2. Then I go to 3, and then I go to the 4. I could choose other ones that would be on the line, but those are the only ones given to me, so those are going to be my ordered pairs. And then I look at where they go to end up on the line and what their y is going to be. So I know I'm going to go from the 0, 0, which is my first point. I'm going to go forward to the 1, and it shows me that it goes up 2. And then I just skip to the 3, and I go to the 3, and I go up to the 6. And then when I go to the 4, I go up to the 8. So when I fill out my chart, I can begin to figure out mentally what my relationship is. It's 0 and 0, and then I go 1 and 2, where I could be adding 1. So then I check my next one. Did I add 1? 3 plus 1 is 4. That's not it. Well, what else could I be doing to the 1? Well, multiplying by 2. So then I could do 3 times 2, that is 6. 4 times 2, that is 8. Once again, those light blue numbers are our thinking. So that's what the book is trying to show you, is that once we plot it and we think about the relationships, we can see what we're doing to the x as a constant to get the y. So I know that each of my y's value is being what? Well, it's 2 times the corresponding x value. So I know that my y is 2 times whatever my x would be. So my answer on this one would be y is equal to 2x, because it asks me to find the equation for the linear graph. And we're going to do this one just because I want you to think about what it's asking you and be able to write it down. Explain how to graph a linear equation. So thinking about how to describe, you have to use words. And when you describe how to graph it, then just go through the process of what would we do. Well, first we would plot our ordered pairs on the graph. And then once I have my ordered pairs on the graph, then I'm going to connect them with a straight line. It's the straight line that shows it is a linear equation. Now, the other thing I want you to think about after you write that down is, well, could I have a linear equation that goes up and then drops down and then goes back up again? No, that is not a linear equation. It has to make a straight line. So if I have a situation where I went up as I plotted and then it dropped down, or maybe it jumped up diagonally and then it goes up, I've done something wrong in my relationship and I need to mathematically figure out what I did wrong. These are going to make straight lines because they are indeed linear equations. All right, going on to practice 1 then. It gives me my relationship that I'm going to use. So if I didn't have this chart here, then I would build one of my own so I could do some work and show my math steps so I get credit for my work. It tells me that I'm going to use the relationship of y is equal to x minus 2. And then I look at my x-axis and I look at what numbers I'm going to use. I have 2, 4, 6, 8, 10. All right, so I'm just going to plug in my information. If I know that I have 2, 4, 6, 8, that's all it tells me I need to plot, and I'm doing this math, then I know I'm going to take 2 from each of those. So I just make my own little math problem. I know y is equal to 2 minus 2, because they tell me that that's my constant. And that y is equal to 4 minus the 2. And y is equal to 6 minus the 2. And y is equal to 8 minus the 2. And then I just solve for those, and that has to be what my y is. So I know that I'm going to go and have 2 minus 2, which is 0, and that's what they told me. That checks out. So therefore 4 minus 2 is 2, and 6 minus 2 is 4, and 8 minus 2 is 6. I showed my math problem that I did. I have my answers, so I get points for my showing the work. Now I have to do what? I have to plot it on my graph, and I have to make a line connection between them. And if they don't make a line, then I didn't do my math right, and I need to go back and check it. So my x, once again, is running. My y is jumping, and it tells me where to run and jump to. So 2 and 0. So I'm going to go forward 2, and then I'm going to plot it right on the line, aren't I? I'm not going to jump up anywhere. And then I'm going to go 4 and 2, and then I'm going to go 6 and 4, and then 8 and 6. And so as I plot those, 2 and 0 stays on the line, 4 and 2 goes up across the 2, 6 and 4, and then 8 and 6. And as I plot them, I can imagine that does make a straight line. So I simply draw my line from the first one, and then I go beyond the last one because it shows me all the other possibilities of answers that could fit into that linear equation. I want to do the same thing with number 2. It gives me the relationship that y is equal to 3x, and a number touching a letter, a coefficient with a variable, tells me to mathematically do what? Multiply. So I'm going to multiply each and every time. Well, what am I going to multiply with? Well, I look at my x's, and it gives me 2, 4, and 6. So I'm going to plug in some different numbers. Well, why in the world would I do different numbers? Because when you first look at it, you think you can do it. We will only be able to plot 2 on that graph because it goes beyond. So I changed my numbers up. Can I do that? Well, I can, because it doesn't give me this chart. If it gives me this chart, these are the ones that I have to use and try to plot on my graph. It doesn't give me a chart to fill in, so I can do any numbers that I know that are there. And I know this first one has to be a 1. And in between the 2 and the 4 has to be the 3. And in between the 4 and the 6 has to be a 5. So I'm just going to build where I can. If I go to the 4 and I do what it says, and 4 times 3, I end up with a 12, and I don't have any kind of line there. And then you have to try to make straight lines with the same measurements and stuff, and that makes it rather difficult. So we're just going to use the numbers of 1, 2, and 3, and I do the math. The math that I'm doing, my constant is multiplying by 3. So 3 times 1 is 3. That would be my y. 3 times 2, because we're going to go to the number 2, is 6. So that's my y. And 3 times 3, I'm going to have 9. And then I plot it. So my ordered pairs that I get, notice parentheses, comma in the center, are 1 and 3, 2 and 6, 3 and 9. If I went to 4, I'd go off my grid, so I just stop there. And then I'm able to connect my lines in a linear equation. That's a steep one, and that's why it runs out of space so quickly, because it takes such big jumps. So here's what I want from you. I want you to make sure that you're following along and understanding this, because I'm going to give you a couple to do on your own here in just a moment. Now this one is where we go in the backwards formation. So I'm not given things I have to figure out and mathematically do. I have to figure out a chart that would help me see the comparison between my ordered pairs in order to tell what the relationship is. So let's look at our ordered pairs. And once again, it goes x, y. My first number in my ordered pair is always my x. So I'm going to draw a chart that I'm going to fill in to see if I can see a mathematical pattern for my relationship. I know my x is my first number, my y is my second. So I have 2, 1, and I write it down. And then I have 4, 3, and I write them down. And then 6, 5, write them down. 8 and 7, I write them down. Now, do I see a pattern that develops? Well, I'm going by 2s here. Now, that's where some people were trying to go directly down on their x or directly down on their y, then figure out the relationship in the last lesson. That doesn't work. These are relationships. These are graphing on coordinate grids. So I have to go across. I have to connect x to y to find a relationship. I can't just say, well, I'm increasing by 2 each time. That doesn't work. It has to go from the x to the y. So when I look, I'm actually decreasing by what? Well, I go from a 2 to a 1, so I'm going to subtract 1 on that one. That's a hypothesis that I have. Or I could say, well, I'm dividing by 2, because 2 divided by 2 is 1. So let's check which one it might be. I take my hypothesis and I go to my next pairing that I have. 4. I had 4 minus 1 and 4 divided by 2. Well, 4 divided by 2 is 2. It's not division. Does the subtraction work? 4 minus 1 is 3. It does work. It proves correct. How about the 6 minus 1? It does give me 5. Or 8 minus 7. Or 8 minus 1, excuse me. It does give me 7. So I know that I can find my relationship by going through and subtracting by 1 each time. So that's my constant that has to be in my relationship math problem. So I know I'm going to have my y is always going to be my beginning. And it's always going to be equal to something done to my x. Or maybe it's just equal to x by itself. But if on this one I see that I'm subtracting 1, then I know that my linear equation is simply y is equal to x minus 1. And no matter what I plug in, I know that I would just take 1 away from it. So if I wanted to do the 10, and I took 10 minus 1, I could check it does indeed take me to a 9. Going to do the same thing with that one over there. I shift over my screen so I have a working space over here. I'm still going to make a chart so I can do some comparing. So I'm going to build my x and my y. Once again, my first number in my ordered pair is always my x. My second one is always my y, and I put them in the order that they're shown. 2 and 1, 4 and 2, 6 and 3, 8 and 4. And then I try to make comparisons and find that relationship going with comparing the x to the y. Not just the x's or not just the y's. So, 2 to 1, well, that's what I had before, and we said we could subtract by 1. Let me check the next one. 4 minus 1. Well, that's not it because that doesn't give me 3. So we said the other possibility was, well, dividing by 2, 2 divided by 2 does give me 1. Does that work here? 4 divided by 2 gives me 2. It does check. Prove it. 6 divided by 2 does give me 3. So I know mathematically what I'm doing as my constant every time is I'm going to take my y is equal to x, and what's being done to the x's, I'm dividing by 2 every time. So if I say that my rule or my relationship is dividing by 2, then my linear equation is y is equal to x divided by 2. And once again, if I wanted to plug that in just to make sure, I could go to the 10 and plug 10 in, and 10 divided by 2 gives me 5, and I can check to see if that's where that takes me on my linear equation, and by golly, it sure does. So we've worked through both types of problems that you're going to have to do for your homework. So hopefully you've been following along, paying attention, because now I want you to do these 3 on your own. It's your turn. Show your work, so you get your points for showing your work. Plot it, and then down here you just need your linear equation and how you would do it. Take the time, pause the video, do it, come back, work through it. So hopefully you have at least the answer for 5. And then you can pause the video and then do 6, and then pause the video and do 7. Or you've done all of them and I'm going to work through them. So we find our linear equation that we're going to use, y is equal to x plus 1, and then we're going to find some coordinates that we're going to use for it. So when I do it, I'm going to go just by the numbers that they show me here. I'm going to use the 2, the 4, the 6, the 8. That's what y is equal to, the x. So I have x as 2, x is 4, x is 6, x is 8. And I'm going to add, like it tells me to, 1 every time. That tells me, therefore, that my y is equal to, well, if I have 2, 4, 6, 8 for my x's, then my ordered pairs have to be 2 plus 1 is 3, 4 plus 1 is 5, 6 plus 1 is 7, 8 plus 1 is 9. You can either show me using the equation over and over and over again, or in your ordered pair, like I have on all the ones that I'm showing work on, I'm just showing that I'm taking my x and adding 1 each time, excuse me, to get my y. That would be showing work as well. Then I take my ordered pair, and I'm going to plot them. I'm going to go to 2, I'm going to go up to 3, 4, up to 5, so on and so forth. Your answer, therefore, then should be all 4 points plotted and a line connecting your points. If you just have the points on there without the line, it's not a linear equation, and I can't count it correct as the final answer. So either this work or this work is what's going to give me my answers, but I have to see ordered pairs. So really this is a shortcut to not having to do that set right there, because I'm still showing the work that I'm doing. But I have to show for my answer point the 4 points with the line connecting them. So if you didn't do 6, pause the video and then come back and check. If you did it, then hopefully you started and we started doing some math, realizing this is a 2-step math equation. I have to multiply and then I have to subtract. So when I get my ordered pairs, then I'm going to go in the order of 2, 4, 6. I didn't go on because it takes me off of my grid, so I only did the first 3. And when I do my work, 2 times 2 minus 1, well, that's 4 minus 1, which is 3. And then 2 times 4 is 5 minus 1. No, excuse me. 2 times 4 is 8 minus 1, which is 7. And then 2 times 6 is 12 minus 1, which is 11. So I have 3 ordered pairs that I can use. I plot them, and then I connect them with what? A line, right? So I have to have my 3 orders. Now notice that took me all the way to the very top of that grid. So I didn't go to the 7 or the 8 because it was going to take me off of the line. But that would be my point for my answer, having the points there and connecting them with a line. Now I mentioned in the video, if you were paying attention and not fast forwarding or skipping or staring off into space, what this answer would be. This one doesn't require any math work at all. You could show a grid if you wanted to, a graph, and write it down, but you don't have to, because I noticed that my X and my Y are the same number every time. And I mentioned a couple moments ago in the video that they could be equal to one another. And the linear equation that shows the relationship to that one is indeed that Y is equal to X. If I was going to go 10 and 10, then that would be on the point, because they're always going to match. On this one there, where they skipped a point, it would be 3 and 3, so they would match. So there's no work to do on that one. You just have to realize that Y and X could be equal to, but they have to be the exact same number. So this is your homework for tonight. 2 through 6 and 1 through 6. It's just about linear equations. Either finding the relationship and writing it as an equation, or taking the relationship, finding my ordered pairs, and plotting it with the points and the line to get my credit. So as you're working through it, if you have any questions, anything that you struggle with, just come and ask.